Now I'm going to look at a couple examples based off the different kinds of triangles. This first one, notice we want to find the value of D and the measure of each side of, notice this says we have an equilateral triangle. And then it gives us the length of all three sides. What I'd like to do for starters is I would just like to draw my triangle. I know it's equilateral, so I'm going to mark that it's equilateral. Now I don't need the words in the problem to tell me that it's equilateral. I have triangle KLM, and then I'm going to put in these three lengths. The length of segment KL is going to be D plus 2. Length of segment LM, that's 12 minus D. And finally, the length of segment KM is 4D minus 13. So somehow I have to figure out what the value of D is. Well, I look at my triangle and I notice that all three sides are congruent. Therefore, I know all three of these things are going to be equal in length. I can write an equation, but I only need two of them. I'm going to take the red and the green, write my equation. I just said they were equal in length. I'm going to start with my equal sign. And then I'm going to put in, well, D plus 2. That's one of the sides. And then my 12 minus D on the other one. Now I just have to solve my equation, and I should have it. What I will do is I'm going to add D to both sides. I'm going to get rid of the 2. Now I have 2D equal to 10. Solve for D by dividing by 2, and I just found out that D is 5. Now that was part of the answer to our question or to our problem, but the other part, it wants us to find the length or the measure of each side. So I could just come over to any one of these and plug that 5 in, and being they're all equal in length, I really only have to plug it into one. I'm going to pick the one that I think is the easiest, and I think the red one's the easiest, so I'm going to put my 5 in there, add on the 2, and find out that the length of that side is 7. Now I'm just going to do a little double checking in my head. I'm going to go to this green one, and I'm going to plug 5 in there and do, well, 12 minus 5, that's also 7. Yep, I got the length of that one. And then my last one, if I take 4 times 5, and I get 20, and then I subtract 13, I'm going to end up with 7 there as well. So I found the length of all three sides being 7. I checked it to make sure that they were all three of them were 7, and I found that my value of D was 5. Now the next one, I want to classify this triangle based off of its sides. And what happens on this one is it gives us the coordinates of the three vertices of our triangle. What I'm going to do is then I'm going to graph this triangle on the coordinate grid. And I'm not going to make it perfect. I'm just going to get ballpark figure where they're at. Point R is at -1, -3, which would be approximately there. Point S is going to be at 4, 5, so I'm going to go over 4 up 5. That's going to be about here. And then point T is at 8, -2. I'm going to call it right there. And I want to now figure out what kind of triangle do I have. Well, my options are scalene, isosceles, or equilateral. In order to know what kind of triangle it is, I'm going to have to know the length of the sides. Well, I'm going to take my triangle and my sides, and I have to find out how long they are. Well, I'm going to just go from R to S first. I can use the distance formula to calculate how long that is. So I need these 2 points. And I'm going to just bring this one down and this one down so that I know that I'm working with these two. And I can use the distance formula to figure out the length of that side. So I'm going to write this mathematically. The length of segment RS is going to be equal to, and now just do my distance formula. I'm going to have to subtract my x values, subtract my y values, and I'll have it. I'm going to put in my r values, so there's the x value at r, there's the y value at r. Go to my s, x value at s, x value at r. And now, very quickly, I'm just going to go through and figure out this length. This is going to be -5. I have to square it. This is going to end up at -8. I'm going to have to square it. So I have 25 plus 64. That's going to give me a length of 89, or the square root of 89. So the length of segment RS is the square root of 89. That's a simplified radical. I'm going to leave it just like that. Come over here and I'm going to write that in here. I'm going to change this. We're going to call it square root of 89, make it pink so it's easy to see. Well, now I need to move on, and now I'm going to have to figure out the length of segment ST. So I need this one, and I'm going to need this one. Take the, oh, I didn't want to rotate them. I just want to bring these two down. So I need to find the distance between those 2 points. And again, do my distance formula. Now I'm going to find the length of segment ST. Again, distance formula. Subtract my x's, subtract my y's, square those two things, and I'll have it. So when I look at point S, x value is 4, y value is 5, t, I get an x value of 8 and a y value of -2. Again, just the work of figuring all this out. I'll have -4 that I have to square. I'm going to have 7 that I'm going to have to square and take the square root of that. 16 plus the 49. Add those two together, I'm going to end up with 67. Square root of 67 is the length of segment ST. Alright, little mistake here. This shouldn't be the square root of 67. Probably already caught that. It should be the square root of 65. So I have the length of segment ST. I'm going to bring that all the way up here. And I know that the length of that is the square root of 65. Right now, I'm able to eliminate at least one of the triangles. I know that this cannot be equilateral because I have two different side lengths. This one's going to determine, well, is it going to be scalene or is it going to be isosceles? If I come up with the square root of 89 or the square root of 65, it's going to be isosceles. If it's anything else, it's going to be scalene. So last but not least, I have to look at point R. Oops. I want that one, and I need point T. And I need to figure out the length of segment RT. Doing the same thing that I did in the last two. Use my distance formula, subtract my x's, square it, subtract my y's, square it, and I will have it. I'll put in my R value first. So there's the x, there's the y. Plug in my t values, there's the x, there's the y. And go through and simplify the mess, I call it. This is going to give me -9 that I have to square. This will put me at -1. Square it, the square root of the whole thing. So here's 81 plus 1. Square root of that is 82. Is the length of segment RT. Come back up here. Just put that in my picture so that I have everything taken care of. This is the square root of 82. Now you should be able to look at that triangle and almost instantly say, well, none of the sides are congruent. That's a scalene triangle. Now we can't do anything at this point in time to determine what kind of triangle it is based off of its angles, but all it asks for is what kind of triangle is it based off of its sides. So we found out that it's scalene, and we've completed the problem. And that will do it for the couple of examples that I'm going to show based on this lesson.